this computer. Okay, we have a regular n-gon.
So maybe target your explanation towards Yi Ming if you can.
Alright. So some regular n-gon, and we have the center of this n-gon, which is called O, and two adjacent points A and B. So now we have the triangle ABO, and we have another triangle. How does the question say this? This is so weird.
Which one do you want?
X, Y, Z.
Actually,
Moves in a place.
saying
Okay. Oh, it's like moving points almost.
oh,
It's like literally moving points.
really?
Like in the literal sense, so not very projective. Okay, so we have like a point Y and a point Z, and these points Y and Z, they move along the n-gon. So basically, like Y and Z start at A and B, and X starts at O, and then Y and Z move such that like the whole triangle moves such that like Y is moving along the n-gon and Z is also moving along the n-gon. Does that make sense? Like it would move to like something like this, such that they're still congruent. Like X would move here, Y would move here, and Z would move here. Yeah, so basically you're like moving a congruent triangle such that two of its vertices like slide along the side of the n-gon. And then you're asked about the locus of the third point. Like where the third point moves as the other 2 points move. Okay. Surely Lucas's solution will help understand this problem.
Famous loss.
Where is it? Yeah, cam scan. Alright. Let C be a vertex of the regular n-gon such that B and C are adjacent vertices and C is not A. Now, due to symmetry, just consider the locus of X. Of X? What does that even say? As XYZ moves from OAB to OBC. Okay. Let us select any Y on AB and Z on BC such that YZ equals AB. We note that if then X is a unique point.
Does his diagram help? He has a diagram at the end.
He didn't even label Z. Okay, there you go. That's weird because like, let me think. Oh yeah, it's because X remains inside the polygon. Alright. So he's saying once we pick a Y and Z with a Y like on this line and a Z on this line, such that like this line is equal to this line. The X here is uniquely determined because the triangle has to be congruent to like ABO. Yes.
Does Yi Ming understand?
Anyone agree? Agree or disagree?
That's a very short answer, huh?
Yeah. I feel like did he show? Let me just skim read this. Due to symmetry, we get that excellent. What the hell? Oh, okay. Oh, what? I don't know if this counts as a complete proof because I was thinking about this as well. It's like he described where the points could be, but I don't think he actually spans the whole thing.
Okay, so this is where we
But like to figure out where like how far it goes is like a huge trig bash, I think.
this is where we challenge
Alright,
Chat
Lucas.
So Lucas,
Do you agree?
you have some controversy in your question one.
Yes. Do you agree that it does not reach every point on like AO, BO, CO, whatever? It only reaches some of them, right? Yeah, exactly. So wouldn't you have to describe? Yeah, because it's annoying. Because like to figure out how far it goes along is just like I think a big dash. Yeah, it is. It is annoying. Yeah, if you want to do it like numerically, it's yeah, it is annoying. Alright, his excuse is it was unclean and unelegant.
Wait, so it's a gap in the proof, but the claims are true?
I mean, he's right. It's just missing like a bit more information.
Yeah. So I feel like throughout marking Lucas's answers, we've really been able to really state very clearly what's missing in people's write-offs. So sometimes things are claimed something without proof.
Yeah.
Sometimes things are claimed without actually suggesting it's a claim. Sort of underhanded claims.
No. Okay. Let's just keep going with this proof.
Indeed.
Alright. We note that if y and z are given x is unique, okay. Let a b o equals alpha. Due to symmetry, blah blah blah. Now consider x prime on bo. Holy moly. Wait, is it? Am I? Oh. Okay. Is this x prime? I think this is x prime. This one. Alright. That is x prime. Where is x prime? X prime on BO such that x prime yz is alpha. X prime yz is alpha. Okay. Cool. X prime yz is alpha. I agree. Now, due to symmetry. Wait a second. What is going on? We get that angle x prime y z equals x prime bz. Okay. True. Therefore, by x prime z is cyclic. So oh no, I'm covering y. So 1, 2, 3, 4 is cyclic. Hence, ybx prime equals ybx prime equals y. Where am I reading? Oh my goodness. Why is marking such a pain?
Huh?
Marking is such a pain.
Oh, yeah.
Yzx prime Why be
Living a day
explained?
in the marker's shoes.
Cause why?
It's only a pain if you care about the accuracy of the outcome.
Yeah.
Just random number generated.
Alright, true. Oh, now it's congruent. Alright. He kind of did like a similar idea to what I did, but like phrased differently. But it is true that these are congruent triangles. Therefore, x is x prime, and so x must lie on BO. By applying this to all vertices. Okay, sure. So like, he's basically said that x as y is between here and z is between here, the x is like somewhere on this line here. Well, I guess the whole line, but yeah.
This is actually drawing on his exam script, by the way.
Oh, I'll rub out the annoying stuff.
I don't know how it works, but I think it's like if you save it, the next time you can't delete it.
Oh, wait,
How would the PDF know it was? I don't know actually. If you save it, I don't know.
Alright, let's complete the proof. This is proof completion. Oh, I can sign right now.
And then we can talk about number theory for half an hour.
Yes. This is probably a 5 or 6. Let me think. I mean, it depends how annoying the like describing the rest of it is. Yeah. You also, yeah, like proving that it's maximized at the middle is like, I guess it's probably not that hard because you can say it's like as you slide it along, it's like smooth, and then I don't know how hard it is, but yes, it is smooth. It is not. It does not teleport. All right. P midpoint xy. Okay, let me like try to. Distance xp is fixed. Yeah, that's true. Wait. Yeah, p yz xp. That's okay. Let me draw this up on the whiteboard. How Alt tab. Here. Alright. Let's draw a new diagram. I need 2 sides. And we're trying to maximize. Oh jeez, this is so terrible.
Hopefully Lucas is paying attention.
Alright, so this is O. Okay, basically we're trying to maximize like this distance from B to Z. Wait, no, I think this is X. Alright, A, B, C, and Y, Z. So what Lucas said is that this distance here is fixed. Let me think. Alpha. This is O. As x moves. Ptolemy's. There's a cyclic quad. These four. Now what does Ptolemy state? Ptolemy states the product of opposite sides equals the product of diagonals in cyclic quads. Is that true? Maximize by sum of product. Yeah. Okay. Let me write this out. So bz times yx plus by times zx equals bx times yz. Okay, so we know stuff. We know these two are equal. Yx, zx are equal. And we know, okay, so let me just write this as yx times bz plus by equals yz times bx. Yz is fixed, so is zx. So these two are fixed. True. So how does that prove it's maximal? Yes. So how do we maximize that?
Which point is Z?
Oh, Z is here. Okay, so we're maximizing bz plus by. And I think this shouldn't be that hard, right? So we have a triangle. Yeah. We have a triangle with a fixed angle up here to alpha and a fixed length. And so let's call this length x, length y. This feels like school math.
Yeah.
How do you show that like x plus y is maximal when x equals y? Anyone know?
Wait, what is this?
So we have a triangle with a fixed angle and fixed side, and we're trying to show x plus y is maximal when x equals y.
Oh.
How does sine rule work here? So beta gamma sine beta on x equals sine gamma on y. Equals like some fixed constant. Y equals sine gamma on C. X equals sine beta on C. X plus Y equals... Surely this can't be that hard, right? Sine gamma plus sine beta on C. Yeah, so we're just maximizing sine gamma plus sine beta, where gamma plus beta is fixed.
Plus B minus yeah. So eliminate C.
Oh, those C's fixed anyway. We don't care about C. So how does...
Use your newly learned calculus.
Oh, wait a second. Maximize this when this is fixed.
Pi minus 2 alpha.
Well known. Well, it does seem pretty well known.
Yeah.
Pi minus... Okay,
You'll do the calculus way.
what's the calculus? How?
So gamma plus beta equals pi minus alpha, 2 alpha, right?
Yeah, well we can just simplify with this, right? It doesn't really matter what it is. It's just some constant.
Okay, so then so the gamma is equal to beta minus the constant. You can just write it all in terms of beta. There's a different constant. Is that the other one big C? Or?
Okay, wait. D. D's annoying for calculus. X. Wait, no.
B.
B. Sure. The sine B beta.
I think it's B minus beta.
Oh, true.
Okay, and then differentiate.
This whole thing with respect to B or beta.
Beta, okay.
So D on D beta equals sine, that is like, what does this equal? This equals to some angle sum. This is something like sine B cos beta minus cos B sine beta. Is this right? Is this the wrong formula?
Oh no, you don't need to
Oh,
you don't need to expand it, you just chain rule.
Really? Oh, that's probably faster. Chain rule. Alright. So this is cos B minus beta. Wait, let me look this up. Times -1. Is this how it works? How does chain work? So differentiate cos B minus beta negative, and then this is just plus cos beta. This equals cos beta minus cos B minus beta. what does this mean? So the gradients. So this, oh, this is maximum when this is 0. So cos beta equals cos b minus beta. So beta equals b minus beta plus something. Okay, whatever. This is good enough. So we get this. Alright. Sure. Okay, we've proven it's maximal.
Wait, did it work? What happened?
Like, you get, I think you get this after you differentiate.
Yeah.
And it's maximal when it's 0, right?
Okay, yeah.
So you get that.
Yeah. Yeah,
And that's like basically sine equals sine b minus beta.
Does that also say that beta you want to
Yeah, like plus 360 or something. Or pi, 2 pi.
No, I think for angles in a triangle.
Oh, yeah, they can't be that big. Yeah, they should just be equal.
So 2 b equals 2 beta, yeah.
Yeah. Okay.
Oh yeah, so the gamma equals beta, yeah.
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 That's all we wanted. Alright, now we just have to look at the case. Where it's like this. Alpha. Okay. X Y Z B A C. How do we calculate the length bx? Okay, we can express alpha in terms of n. Alpha is just pi times n minus 2 on n. Or 2n. Right. So what is half yz squared? Huh? Half? Okay, half yz squared equals this power of a point. Okay, power of a point. So we get half yz squared equals bp times px. So this we can express in terms of okay, we'll just let, I mean the side length is kind of, okay, let side length equals 1. So yz is just 1. Yeah, so this is just equal to a quarter. It's bp times px. bp times px. Now, oh, I mean, we can literally just figure it out, right? Because, this is half, half. So this length here is just the sine tan alpha equals px on half, and tan alpha equals tan alpha equals half on BP, so px equals half tan alpha, BP equals 1 on 2 tan alpha. So that means Bx equals half tan alpha plus 1 on 2 tan alpha. And then we can express alpha in terms of n. And then express alpha in terms of n, and you can scale it by the side length if you want.
Is this your approach as well, or different?
Oh, we're just working on it together. Because neither of us like actually did it. Oh, okay. But I mean, we expressed it in terms of n, so that's good enough, right? I think there's still a few holes in terms of like why I can't go like on the other side, but
is that the end?
well, we have an answer now. We have a concrete number, so.
Oh. Is the natural checkpoint to stop?
Let's stop recording.
Or is it over though?
Is Lucas happy? And get this thing. Yes. Okay.
Alright.
Yeah.
Alright, let's finish the last half hour with number theory.